SMO 2007 junior short problem. Problem number 34. Now this problem states that we want to find the smallest positive integer such that the product of three natural numbers n times n+1 times n+2 is divisible by 247. All right, now usually when you see something like this, you expect the prime factorization to be of 8, and this problem is no different. In fact, this is more or less just a direct translation, and this is about as direct as I could get. I wrote down the product of the three natural numbers, and I just divided by 247n, and we're looking for the smallest possible n that will meet the task. Now notice that n equals 1 is not a solution to this. If we have n equals 1, then this product is 6, and 6 certainly, I mean, almost goes without saying, but 6 does not divide. Now this vertical bar means divide, and the slash means does not divide 247. To divide a number, you have to at least be equal to the number or more, right? So we can rule out n equals 1. N equals 1 is not a solution to this. So that's why we can just divide through by n right here. N's not an answer. So we get this nice little form. And this turns out to be quite useful, because what we know is that there's going to have to be the product of consecutive natural numbers in the process. Somewhere along the way, we're going to have to see consecutive natural numbers. Now, what I did, I wrote down the multiples of 13. We have 13, 26, 39, 52. And then these are the multiples of 19 right down here, 19, 38, 57, and 76. Now, okay, so we already know that n equals 1 doesn't work. And so what we have to do is just search for multiples that are consecutive, because that's what this says, right? n+1, n+2. So we have to search for numbers in this list that are consecutive. And you don't have to search far. You have 39 here and you have 38 here, right? Okay. Now and you can see, I mean, it's a requirement. You can't even consider it. It has to be a multiple of 13. It has to be a multiple of 19, and also they have to be consecutive according to this statement right here. That's what the structure of the algebra does for us. And so notice right here that if you pick, this would be 38 right here, and this would be 39. Okay, so in other words, n+1, let me just write it down. You would have 38 times 39. It's supposed to be a multiply symbol, folks. 38 times 39 over 13 times 19. Now it's backwards, so to speak, but it's still accurate. So you see what happens here. You have 38 over 9. Not that we even had to do this because we've already proved it basically, but 38 over 19 is 2. All right. And so this would actually be equal to 2 times 3, right? Okay. So that's what we mean. In other words, for something to be divisible, 13 times 19 is the prime factorization. So for it to be divisible, for the original expression to be divisible, this would have to be a natural number. You can't get a proper fraction. You would have to get a natural number, and we did get a natural number of 6, right? Okay. Now the fact that it's equal to 6 is not really relevant, but what we do pick up right here is that n+1 is equal to 38. And of course, n+2 is 39. But what is the question? Was the original question says find the smallest positive integer or natural number n such that these conditions prevail. And so this certainly implies that n is equal to 37. And that would be the answer, ladies and gentlemen. We didn't have to go too far into the list. Now, the drawback to the way I did it, this could have been designed where the numbers happen way out there. We kind of got lucky here that the 39 and the 38, the consecutive multiples, one of 13 and one of 19 happened like that. I mean, I could see a problem where that would be further out, and that would make this exhaustive approach that I've adopted be a little suspect. I know there's probably a more intelligent way to do it, but this is the answer. N is equal to 37. Let me know what you thought.